We're going to do 3-1 exponential and logistic functions, part 1. So today we're going to learn about the exponential functions. The functions f of x is equal to x squared and g of x is equal to 2 to the x power each involve a base raised to a power, but the roles are reversed. So first we have x squared, and our variable x is our base, and the exponent is the constant 2. And what changes here would be the value of x, so what is being raised to the power. And then for g of x, 2 is our base, and our variable is the exponent x. These are the two different graphs. Here we have y is equal to x squared, and here we have the exponential function 2 to the x power. So the definition of exponential functions: if we have a and b be real number constants, an exponential function is an exponential function in x is a function that can be written in the form of f of x is equal to a times b to the x power, where a is a non-zero, b is positive, and b does not equal 1. The constant a is our initial value of f, and b is our base. So this b is our base, a is our initial value, and our initial value will also be the y-intercept.
Okay.
If we need to identify whether the functions are exponential or not, we need to see if our variable is in our exponent. And if we have a base, so here we have a base of 3 and an exponent of x, therefore this is exponential. In number 2, we have an exponent of -4, so this is not exponential. -2 times 1.5x, we have an exponent of x, we have a base, and we have our initial value. Therefore, this is exponential. We have 7 times 2 to the negative x power. We know that negative x power could also be written as 7 times 1 over 2 to the x power, and this is exponential. And last, we have a power of pi. Pi is not a variable, so this is not exponential. So exponential functions. If we have an exponential function, a times b to the x power, we can have a growth function or a decay function. So if a is greater than 0 and b is greater than 1, so if our base is greater than 1, we have exponential growth, and b is our base factor, our growth factor. And then if we have a is greater than 1 but b is less than 1, so our base is less than 1, we will have exponential decay function, and b is our decay factor. And this is what our graphs of exponential functions look like. We have f of x times f of x is equal to b to the x power. Our domain is all real numbers because we can go to the left and to the right. Our range is from 0 to infinity. We are continuous. We have a horizontal asymptote at y equals 0, which means our graph will never cross the x-axis in this function. We have no vertical asymptotes. We have no local extrema and no symmetry. We get this horizontal asymptote from the number out here, d. So if we're adding a number out there, that would be our horizontal asymptote. If we do not have a number out there, then our horizontal asymptote will be 0. As you can see, if we are increasing, that means our base is greater than 1. And since we are increasing, we are exponentially growing. And here, to our right, we are decreasing. As we go from left to right, our y values are getting closer and closer to 0, which is our horizontal asymptote. Therefore, this is decaying. Then we have the exponential function f of x is equal to e to the x power. And this looks very similar to b to the x power. But what is e? So we have f of x is equal to e to the x power is increasing, and it is an exponential growth function, so e has to be greater than 1. And e is, so e to the x power has special calculus properties that simplify many calculations, so e is called the natural base of exponential functions for calculus purposes, and f of x is equal to e to the x is considered the natural exponential function. So the definition of e is the limit as x approaches infinity of 1 plus 1 over x to the x power. We can have an exponential function and the base e, so f of x is equal to a times b to the x power can be rewritten as f of x is equal to a times e to the kx power, where k is a number constant, and if a is greater than 0 and k is greater than 0, the exponential function is growing. And if a is equal to 0,
Richard, could you please?
a is greater than 0 and k is less than 0, then we have exponential decay. Here, e to the 2x power, 2x is greater than 1. If k is greater than 0, this is exponentially growing. Negative x means we are decaying. Positive x means we are growing.